Hello everyone, this is Shankar. In this video, I will explain about most important multi-threading concept called completable feature in Java. It is one of the concept in multi-threading. This video is suitable for the both process and experience candidates. So let's get started. So this video I will divide it into two parts like theory part and one practical example. So let's I will add some bullet points about completable future. So why completable future? What is the future? Future, by using future we will get a we will get like blocking mechanism like so like future dot get, it is the blocking until completing the task or thread it will block that limitation is overcome by the completable feature, right? And while using the feature we need to handle exceptions manually, but if we will use completable feature exception handling, I have some methods. I will explain point by point. So created to overcome limitations of the future API. Future API. What are limitations? Future is a blocking mechanism. We need, if we want to result, we need to call future dot get. So it is a blocking. It will block until completing current thread or task, right? One another, we need to handle exceptions manually. Second, there is no support of chaining in future, but in completable future we have the chaining as well. We can also in completable future we can add results, two task results we can combine as well, right? Created to overcome limitations of the future API. Allows non-blocking result processing using processing using, then apply, then accept, and then run. So this is the second point. It is very important. Allows non-blocking result processing using, then apply, then accept, and then return, then run. So allows non-blocking result processing using, then apply, then accept, then run. Right. Third point. So supports method chaining for sequential sequential async operations sequential async operations. Fourth point, provides provides built-in built-in exception handling using few methods like exceptional and handle. So fifth point, allows async execution without manually creating threads via run run async method slash and supply async. So this is the fifth point. So allows async execution without manually creating threads via run async and supply async. So supports combining multiple async tasks using using then then combine then compose all of all of and any of any of any of methods. So these are the 6 points very very important about completable feature. One more time I will revision these points, these 6 points. Completable feature theory points. These are the 6 theory points created to overcome limitations of the feature API. Allows non-blocking result processing using then apply method, then accept method, and then run method. Supports method chaining for sequential async operations. Provides built-in exception handling using exceptional method and handle method. Allows async execution without manually creating threads via run async and supply async. Supports combining combining multiple async tasks using then combine, then compose, then combine, then compose all of and any of methods. So one more time I will repeat. These are the very very important points. Completable future in multi-threading theory. First point created to overcome limitations of the future API. Allows on-blocking result processing using then apply, then accept, and then run methods. Supports method chaining for sequential async operations. Provides built-in exception handling using exceptional and handle methods. Allows async execution without manually creating threads via run async and supply async. Supports combining multiple async tasks using then combine, then compose all of and any of methods. So what are the limitations of future? So future, if we want future result, then we need to block like future dot get. It is blocking mechanism. It will block until current task or that completion. This is the one it is resolved by using this second point. Allows non-blocking result processing using then apply, then accept and then return, then run, right? So supports method chaining for sequential async operations. Future will not support chaining method chaining. So future we need to handle manually exceptions manually. Here compatibility feature provides built-in exception handling using exceptional and handle methods. So allows async execution without manually creating threads via run async and supply async. So here also feature also we need not to create any thread, like it will submit method will be there that will be created threads. We need to pass that some logic to submit. It have some two overloaded methods like runnable, callable like that. Top of that this run async inside run async maybe submit method will be there. Suppose combining multiple async tasks using then combine, then compose all of and any of. We can also combine multiple tasks. So these are the limitations of feature. These features are overcome by the completable feature. So these are the benefits by using the computable feature. So let's get started developing one small application. So I will open the STS IDE. In STS IDE, I will create one application for that. So I will do just some addition operation. So it is easy to understand beginners and experienced candidates. So wait until it will open the STS IDE. If you are attended any interview, please mention these 6 points perfectly with confidence, 100% confidence. Please explain. So you will be selected for that interview. You must explain in confidence, right? These are the very very 5 important points about completable feature. So launch STS IDE. Wait some time, it will be open. So it is loading now. While you are practicing Java, you can use any IDE like Eclipse, STS, IntelliJ. Everything is fine. So let's close programs. So these are the classes are there. Let's add one class. So like completable future test, completable future test, completable future test. Let's select the main method. So quickly we can finish this program. So first let's create one private method. Private for it's an operation. Private static int add int a comma int b. So return a plus b. So this is the assume like a business method. Let's create now completable feature method. Public. So return type as of now I don't know return type. Let's ignore. Add number. So int a comma int b. Int b. This is one method. Suppose assume like a as of now void method. Void method, right? So assume like a void method. So we need to return response. I want to print here. This main method, I want to print the result. Then it is not a void. Void it will not return anything, right? So it will be completable feature. Completable, completable feature. We need to pass. T is a integer. Integer. So integer, right? So it is a main method is a static. So I will also make it as a static. So return, return. So in computable feature, most of the methods are static. So dot. In this video, I will use two methods only. Next video, next couple of videos, I will cover multiple completable feature methods. Right? This I will use. Is expecting supplier. Supplier have one method. It is a functional interface. Right? See which method supplier have. Supplier have get method. It will return T some object. Right? It is a static method available in completable feature. So let's use lambda. Lambda. Let's use lambda. Right? So supply async. Now what needs to do? Add will be there, right? Let's pass here. Add a comma b semicolon. So supply async. Right? After that, if any exceptions, if any failures are there, then which method? Exceptional. Exceptional. It is a function. Function have which method? So function also. It is a functional interface. Functional interface. So suppose system dot out dot println system dot out dot println. See it is giving some error. Let's check where we done some mistake. So completable feature supply async. So lambda added exceptional. Then you can return if any exception return 0. Here system dot out dot println of error occurred, error occurred plus plus. So what we taken variable, we need to take here variable error, error dot get message, error dot get message, semicolon. So some issue here. Let's check supply async. This is single line, right? So brackets optional. Let's remove brackets. So let's remove brackets. Semicolon also optional. So like this, then there are here two lines are there. Selector Control Shift F, Control S. So here, if you want, we can also add the brackets. We can also add the brackets like this. If we add, we need to use return, I think so. See here, we done small mistake here. So supplier sync, this is the so supplier lambda expression. It will have one get method. It is a functional interval. It will return some object. So we need to add a return. This is right. After that, so here we need to close. We need to close here. This is the supplier sync. After that, if any exception like a try catch. So this is the program. So let's add this into the here. So we need a result. I want a result, right? So I am using main method. I am adding here add number. Suppose 10 comma 20. I want result as well. This method invocation of the I need a result. So in future, if I want a result back, then we need to use get. Here we need to use the then accept. There are multiple methods are the result. Then apply, then accept, then run. These are the result, non-blocking result processing. So I need a result. For that, then I will use then result. I will use here then result. Right? Dot then accept. I will use then accept. Right? Suppose take a we need to pass here consumer. So some so system.out.println suppose some message result colon plus result result. So single line. So this semicolon is not required. Semicolon is not required. Semicolon here. So we can also use brackets. If you want, we can also use cut this control X paste here. So remove like this. If multi lines are there, multiple lines, we need to use brackets. If single line, brackets are optional. Optional. See, I will explain this program. This is the first example of completable future. So I am doing here. It's an operation. This is the it's an operation logic. This is the completable future logic. So I want result back. That's why return type is completable future. Result type is a integer. So completable future supply async. Here supply async for what? So see supply async allows async execution without manually creating threads. So without creating manually threads. a JSON. So thread a JSON. We need this supply async without creating threads manually. Assume this is like a one task, one work. So we are performing one work by using the completable feature. If any exception is occur, we are saying print this exception message and saying return zero at the result. So we need a result back, right? So this method is we have set like completable feature return integer. It will return some result. We need to capture that, right? So this completable feature dot then accept. I'm printing the result. We can also write like completable future equal to cut this control X. After that completable future dot then accept. It is a consumer. Let's check consumer have what method. Consumer have accept method. It will we need to pass one parameter. There is no return void type. So now let's store result in one variable. Let's take functional interface system dot out dot println print the result colon so result semicolon. This way also we can write otherwise directly we can also write like previous. So instead of this cut this part instead of like this also we can do, right? So I am commenting this code control as run as Java application. See result 30. So in this video, we are successfully understand completable feature in Java in multi-threading. Thank you for watching. For more videos, please subscribe to this YouTube channel.